folks, I think we'll just make a restart. Okay, we're obviously on Tuesday. It's the 10th of June, and before getting down to business, I'd just like to welcome everybody to the last session, or the last of our online sessions, that's going to focus on assessment and computing science courses before our long-awaited summer holidays. This evening's the third STACS event that we've hosted, and we're really looking forward to continuing this journey with everybody after the holidays into session 2025-2026. If you didn't manage to catch our first two sessions, then they were focused on the skills assessed by question writers in the exam paper, and then we also considered the importance of marking instructions. All the videos and resources for both of those sessions can be found on our STACS Connect channel. Just let us know tonight if you've had any issues trying to access these on chat, and we'll give you a little hand. In tonight's session, we are going to be focusing on the use of formative assessment and how that can be used in the classroom during normal learning for assessments for students and how to provide them with some feedback. And then, of course, the use of formative assessment strategies. These enable teachers to identify any patterns where students are weaker and go over the theory knowledge with them prior to any summative assessments. Hopefully by now everybody has managed to access the Miro. The link for the Miro is in our chat, and if you can't get access to it, just put a wee message on the chat and the background team will help you get some access. So if you already haven't done so, can I ask you just to turn your cameras and turn your mics off during the presentation? That just helps with kind of minimising the background throughout the session. And then if you're asked at any point, just turn them back on. Hopefully you have a chance already to have a look at our first frame. This is going to tell you just a little bit about us and the assessment team, who we are, what we're doing, and you can read that throughout tonight or later on in your own leisure. What you'll also see on that first frame is our agenda for tonight. So we started just after 7. We're hoping to go through this for 15 minutes, a wee quick reminder about housekeeping, how to use the Miro and what's formative assessment. Then we're kind of going to move on to topic 1, which is going to focus on peer instruction. Topic 2 is going to show us how we can use formative assessment to teach the content from web design and development. Topic 3 is formative assessment strategies in database design and development. Topic 4 is going to cover computer system content, classroom learning activities that can be used to support that. Then moving on at 8:10 to topic 5, where we'll consider a variety of formative assessment strategies that can be used in the software design and development content. At 8:25, between 8:30, we're hoping to finish the evening off, gather some feedback from everybody that's taken part so that we can focus this on some future sessions. And then, of course, we've got the optional after party, which is an opportunity for you to ask us any unanswered questions, or if you just want to come in, have a wee chat to the team to get to know us a little bit better. If you don't and you've had enough of us by 8:30, we will absolutely not be offended at all. Okay, so for anyone who hasn't participated in our last session, we are using Miro tonight to host our presentation. Some of you might be familiar with it, but let me just do a little quick recap. So most of the time when there is discussion going on, you will be in presentation mode, and that's what you see on screen just now. This is going to allow our presenter to take control of what you are seeing and move through the frames without you having to do any of the hard work. When not in presentation mode, you might be asked to follow the presenter. This can be done by choosing a little name from the drop down at the top right of the screen, and if you click on the little name, then a wee eye should appear. If you ever wander off from your presenter, you'll see a prompt at the bottom of the screen that will say return to presenter. If you click on this, you'll be able to jump straight back to them. Using the Miro board when not in presentation mode can be a little bit overwhelming because we've got cursors from everybody just flying all over the place. So as much as possible, we would ask you to use the cursor park situated at the side of each frame. This just makes sure that everybody can read the content on the frame and it isn't covered by any cursor or your name. If you prefer, remember you can always switch off the other cursors You can do that at the top right by clicking on Hide Collaborators cursors. When you're asked to type on any post-it notes on the screen, you can literally just grab a post-it note from the stack and type away. You will notice that the text does adjust in size. It will get really, really small, but don't worry about that. We can zoom in to see what everybody is saying. And there should be enough sticky notes on the pile for everybody. If you need an extra, just feel free to grab yourself a wee extra. At various points throughout tonight, you might be asked for a reaction or a little thumbs up as part of any interactive content. And during presentation modes, those options should be at the bottom of your screen, nice and easy for you to select. They'll pop up on the screen for everybody to see, so that's a nice, easy way for us to see your feedback. We always appreciate a wee emoji if you think something's nice or if it's making sense to you. And I did notice that somebody just popped that up a wee second ago. If at any point in time you're struggling with anything on the Miro board, then feel free to pop something in the chat and we'll try and get back to you as soon as possible to make it nice and simple. So hopefully that's all making sense. If you could just drop me a wee thumbs up emoji just now, if we're feeling quite happy and confident to move on and get our evening started. Fantastic, thanks folks. Okay, so moving on. So what is formative assessment? So before I go any further, it's a good point in time to pause and get some audience participation. So over to you, if you could grab a little post-it note and just jot down a few words to describe what formative assessment looks like in your classroom. And I'll just give everybody a few moments to get that done. So that's hopefully just broken the ice a little bit, got us starting off thinking about formative assessment, getting you thinking about how that works in your classroom. So thank you to everybody for those responses. We've got some really good examples. So let's move on and actually think, well, what do the researchers and educationalists say about formative assessment? So formative assessment is a type of ongoing assessment, and it's importantly used during our learning process to monitor students' understanding, provide feedback, and guide us teachers into our next steps in delivering the course content. It's also really crucial that we embed it in our lessons, as it not only gives students feedback on their journey, but it gives us feedback on our learners' journey. What do we need to improve the understanding for some or for all of our learners so that every single person is successful? It helps us identify misconceptions. And if we can identify misconceptions quickly, that means we're going to figure it out before they get ingrained in students' thinking. It also encourages students to take an active, participative role in their learning and encourages them to reflect on their thinking, which is vital in our problem-solving based subject. And finally, formative assessment takes place in lessons. It's not like summative assessment at the end of a topic. Formative assessment focuses on the learning and the improvement of skills, not just the grades that come at the end. Throughout this evening session, you'll notice little books on our frames. These are clickable links that will take you to websites that will just provide a little bit of further reading and insight to support our content. During each topic, the tutor will introduce several formative assessment ideas that you could hopefully integrate into your classroom teaching. And please remember that you'll be able to access all of the resources that we've discussed during tonight's session and more in our swag bag, and more details of that will be available at the end. But I think you've heard enough from me just now, so I'm going to pass over to Kim, who's going to lead us through a little bit about peer instruction.
Thanks, Michelle. Everyone who's in the Miro, just before I do my section, if you are not following the presentation, please remember just to go back up to the top right-hand side and press join, because I can see that some people are still not managing to follow Colin again. So hopefully you should be able to see the frame now that says what output will the following programme produce. If you're there, you're in the absolute right place. Okay, so hi everyone. Let's get those cogs turning to get us started. On this frame, you can see I've got a block of code, and your task is to work out what it is that we are doing. I'm going to give you all a couple of minutes to read it over, and once you have an idea in your head of what the answer is, I want you to give me a wee thumbs up. So don't type any answers anywhere, just give me a wee thumbs up of what you're kind of thinking the answer would be. Okay, so most of you have had a little look over it. I'm going to make it slightly easier and make the answers multiple choice for you. So what we've got here is a little poll. There are 4 choices to choose from. Let me just start the poll so when we're ready we can. Right, 4 choices to choose from. Have a read and see if the one that you were thinking of the answer is there. And if it is, vote on what you think is the correct answer. Okay, so it seems that for the most part, we've agreed on the answers here, but the importance of this type of question, however, is not really the answer in the question itself, but rather in the explanation that we provide for why we've made this choice. So as teachers, we already naturally do this in our classes, but can be a bit more tricky for students. And as they panic, they often just pick what everybody else has selected and they hope for the best, okay? So let's talk about the why behind the answers that we have here and what we might be expecting from the pupils as to whether the answers might be correct or not. So let's have a little look at answers A and B. Nobody went for that one. So those two can actually be lumped together as mutually wrong because we know this, but because regardless of the value of the variables themselves, the output line at line 6 that we can see in the code there clearly shows a concatenated sentence that has area and perimeter both being mentioned in it. Therefore, those answers are automatically wrong. Okay, if we look at option C, which is the answer that most people voted for, this is actually the correct answer. So well done if you selected that one. That's because the program will output the wording in that sentence and the value of area along with the kind of initial value for perimeter. Although a perimeter value was calculated in the function, it's not actually returned to the main program, and therefore that's just left at the initial value of 0. Okay, for option D, we could hope that the pupils would mention the fact that the functions can only return one value. That would obviously be that higher order thinking. And in this instance, only the area is being returned. So therefore the perimeter is calculated but isn't returned and as a result doesn't appear. And you'd be hoping that pupils would be telling you those sort of conversations when they're voting rather than just being multiple choice. Now, this question is more than just a multiple choice question as a starter. So let's have a little look at some of the reasons why. So these type of questions are called peer instruction questions. If any of you were part of like the Plan C upskilling that we did a few years ago, where the course has changed, you might have actually seen them before. They're one of the resources that I still use in my practice every single year, and they really help the pupils understand a concept or a misconception loads better than not using them. Peer instruction is a pedagogical technique which was developed in physics actually years ago, but has since had considerable success in computer science. Essentially what happens is you have a multiple choice question, it's posed to a group or a class, and the pupils are asked to solo vote first on what they think is the correct answer. And this can be done in a number of different ways. You could use clickers, for example, QR codes for like Plickr style, you could use online voting, individual whiteboards or show me boards, or I often quite just use like a eyes closed, hands up sort of thing to take in the votes. I like to, when I'm doing it, keep the answers anonymous between the pupils and the teacher for the first vote, as I think it's really good to get a feel for who is understanding this initial answer, like, or who's not, who's getting incorrect. Once the pupils have voted, the class is kind of meant to be split into groups, and then the groups are asked to discuss their options, make it clear that even if they all agree on the correct answer, they should still be kind of discussing the why they all agree. Why is this answer right? Why are the other answers incorrect? And it's important that the members of the group or the team that the kids are in can justify the group's choice completely. So everyone should be able to answer those questions. Hopefully at this point after the discussion, each group will have come to consensus about what they want to do their team vote for. And at this point, the teacher then asks the group to publicly share which answer they've decided as a team to go for. And it's then our job as a teacher to facilitate a kind of class-wide discussion on what the final class answer should be, with justification, of course, prior to revealing the correct answer. Hopefully, the stronger pupils in your class have at this stage helped convince the other members of your class of the correct answer, and the final stage is really just confirming what the class in total has concluded. But sometimes when you get to this final stage, the pupil's final answer may be wrong, and that's the time where you as the teacher need to step in, unveil the correct answer and discuss why they were wrong. This isn't always as easy as it sounds, but again, we're always kind of brought back to that why. Why peer instruction over other questioning techniques? Well, studies, one of the ones completed at the Ontario Institute for Studies in Education at University of Toronto, they've proven PI to be very impactful. Peer instruction has shown to improve final exam performances over standard lectures. It reduces failure rates, it's contributed to increased retention, and it is widely valued by students. They really, really enjoy it, and I like that's true. I can see it from my classroom. It can be hard to obviously completely evaluate what this specific questioning technique impact has within different levels of learning, and all learners obviously have a different level of skill, but research has shown that class-wide led discussion, that bit at the end where you're discussing with everybody, following them actively talking about themselves, that's the most valuable contribution to the success of this strategy. I think statistically wise, around 22% increase in pupil performance was shown after the use of this as a class-wide technique. But that being said, even a 14% increase was shown with just the pupil discussion. So it's important to consider, however, that this is only going to really work if you've really considered the relationships in your classroom placement, seating plans, and then when teacher input is being used and how that's being used effectively. Often I find that when I use it in my class, I completely move the pupils about so they're not sitting next to their peers. I think it helps when pupils are discussing it, that they're discussing it with pupils who aren't necessarily like they're close to or ones that they know well. And that way there's no predetermined like who is the smartest person in the class, because sometimes when you've got closer like friendship circles, they'll automatically be like, oh, that person knows the answer. But you have to be careful because you need to try and develop a community of sort of trust that facilitates good and effective communication in your classroom, which can be a wee bit tough with computing science pupils sometimes. And there's that danger that some pupils like might completely disengage if they don't feel comfortable enough to state their opinion. So it's a bit of a tricky balance to achieve to get it right. What I've done on this slide is I've added a couple of links to academic research on the use and benefits of peer instruction if you want to have a look at them at your own leisure. In case you want to look at any of them, they're up on the top right hand side on those little books. And I'm going to finish off my section at looking where we can make a use of this in our actual classrooms. So although it seems easy and obvious that PI questions can be used for coding and checking that various constructs work as intended, like that's where it's mostly used, it's good to remember that actually this type of question technique can be used in all areas of computing science and national qualification courses. On this frame here, I've added some examples of this in practice. So you can see, given the right context, you can technically use PI for any stage, any level, or really any subject, but it works particularly well for computing due to the high level of problem solving and that sort of like common misconceptions which arise in the content of our courses. So let's have a quick look at how we can use this in different sections of some of our courses. So you can see this one here in question 1 is a National 5 Systems question, getting pupils to think about where in the computer data is held during operation. It's bringing in bits of software development knowledge too, but it mentions the running total or variable types, but hopefully that wouldn't confuse the pupils too much and they can still drill down to the important information. So where is the data held during the program's running? And we're hoping that they would know at this stage it's the RAM and be able to justify why that's the case. This next question here is another programming one, but this time it's from National 5. So the focus is on the common error that pupils can mix up during the standard algorithm of a running total. If you look at the code closely, you'll actually see the total is not incrementing every time the loop goes round, but instead it's being replaced. And one of the more complex National 5 concepts, that's one of the ones that they get tripped up with quite a lot. So you can some really good high quality discussions with pupils around the tables when they're discussing it for this one. This could easily be adapted to a programming language of your choice as well. So it doesn't have to be written in SQL reference language. You could obviously do it in Visual Basic or Python in particular if that's what it was that you taught. This next question here is also a National 5 question, but it's for databases and it's about sorting. So a sample output has been provided, very similar to what you'd find in an exam paper, but instead of asking the pupil to work out the sort order, they have to justify which of the answers is correct, but also why the other ones are incorrect, which is sometimes part of like a bit harder. So noticing how this has more the standard, it has more than the standard kind of 4 answers that you have. So it's not strict in PI to have 4 answers. A lot of the examples that you'll see do. You can have as many or as little answers as you want. You can just choose what's appropriate to what it is you're trying to ask, as long as the students have time to be able to justify their thoughts for all of the answers. And the final example here is a higher web one using the on mouse over, on mouse out JavaScript tags. They're calling functions to change an image, and the pupils need to work out what the functions are doing and then justify their answer. Again, this is being used to get that deeper level of understanding by explaining the code to a peer or to the class. Again, I've added to a link to a wee website at the bottom there on the bottom right-hand side. This last example that I got actually came from that website. And it's kind of based a little bit on some of the old ISDD versus STD units, but there's still plenty of relevant content that you could use just now for your classes or in BGE. Plenty to get started anyway, if you want to kind of see the format of the questions. And you might want to come back on and grab that link later on to have a little go of it. So now that we've had a look at some different types of questions, let's finish off by having a look at where we might use them. So here are some of the places in my classes I actually use them just now, but you might find that you use them in different places. A great way to get the class of the kids in your class to sort of leave thinking, as I call it, when they're thinking about a topic, is to use a PI question as an exit pass. This is great with something if the use of plickers, if you've ever used them, where you can quickly grab everybody's answers as you leave the room. And if you haven't used them before, basically what they are is every pupil has a QR code, and depending on how they hold their QR code up, they can take in the answers A, B, C, D on an app. If anyone's got like iPads or things they use within schools or Chromebooks, it's a really quick, easy way to do it. And basically you could just scan the kids as they leave your classroom. It's nice to know which individual pupil voted for what to kind of keep a track of their own personal progress. But once you've gathered that information, the pupils can leave, and in the corridors they can discuss as much as they like about the problem that you've left them with. And then once they return the next period, you can use the same question as a starter, which is a great way to jump back into what you were previously learning and see if they've managed to retain or understood, or even maybe had some of those high quality questions like outside of the classroom, and see if they get the content. The most common use of PI questions that I personally use in class is to assess prior knowledge, or sometimes if I've got crashes in the class, kind of raw talent at the start of a new unit. So it works really well with software development, obviously, as you can make it a question with maybe poor readability, so even good pupils might get tripped up. But it doesn't have to be in a specific language, but rather like focusing on the problem solving skills that we use to train the kids. I like to like reassess and repeat the task again at the end of a unit. So I usually do it at the start of higher STD and at the end to see how much the pupils have improved, and to give me a quick indication of maybe who isn't getting some of the logic. It gives me a nice quick overview to see who to focus on when helping during revision that comes prior to like end of topic assessments and stuff. Another good example is to use PI to focus on common misconceptions. You know the ones like if you're looking over 2's complement, students often make mistake about the sign bit's value, which side you fill up the mantissa from, like the sign bit is included in the mantissa's bit value and all that sort of stuff that you get in with 2's complement. So what you could do is use a PI as a kind of worksheet, which you can see here. There's some examples on the board, and then have listed at the top the common misconception, and then a question with answers, and then have a space for the answers to be justified or unjustified, depending on if they're right or wrong. And this can be issued as a classwork, as a homework task, where pupils are given this PI question and then asked to justify whether the answers are correct or incorrect. It might even be a good activity to get pupils to make up their own PI questions to share with each other, allocating perhaps their own common misconception. You could give them a focus to assess, and that should help them hone their understanding and further even still. And it could work well with the right pupils who've had exposure to PI questions in the past, potentially, and understand how they work. So hopefully this has given you a wee look into peer instruction and how you might put it into practice in the classroom to help formatively assess your pupils, as well as bring a bit of class discussion as to what can be some very higher order thinking conceptions. I've collated some examples of PI questions with answers and justifications for you guys to try it with your pupils, but I've also popped them in there, a copy of the template, so they're all going to go in the swag bag for you to access a little bit later. And as I said, the template's there, so if you want to use that to get your kids to try and make up some by themselves and give them a misconception each, then they could have lots of fun. So that's my section over. Next up is Colin, who's going to be chatting to you about some of the other formative assessment techniques and how he has specifically applied them when teaching web content at National 5 and higher. So over to you, Colin.
Thanks, Kim. So as Kim said, we're talking web for this section. One good way to get people started in web is to give them some correct code and then ask them to draw what the output would be. So you could initially just give them a sort of rough sketch, and then they could build that up into something that looked a wee bit more artistic. So it could start with just kind of squiggles for paragraphs and boxes for images, and then you can get the coloured pencils out and you can go for something that's a wee bit more artistic. The example shown was actually AI generated, which is why it's so beautifully drawn rather than my artistic abilities. Using this type of activity, you can get the pupils to kind of see what correct code looks like, and then they can refer back to that correct code when they're doing their own tasks and they're writing their own code. So they get to look at the sequencing of the code, so knowing that the heading homepage for Hector the Inspector is going to appear above the text asking whether you like their fancy hat. They can realise that the tags like the H1 and the P don't actually appear on the page itself. They learn how to work with CSS rules, targeting different specific elements, or in this case, we've got IDs like important and very important. And as a teacher, you get to see if there's any misconceptions, like a title appearing on the page or styling that hasn't been applied. And if there's images involved, of course, you get to see who the artists in the class are as they all try and draw a picture and come up with different interpretations of Hector and his fancy hat. The complexity of the page and of the code that you give them can increase and decrease in length, and you could, as an extension task, get the pupils to actually go away and code the page and see how closely their completed page matches up with what their kind of expectations were. The other thing that you can do is pupils hate finding their own errors, but they absolutely love pointing out your mistakes. So giving the class a web page with an error on it, like this one, and then asking them to evaluate it to find the error. So in this example, the error is pretty straightforward. It's bullet points when it should have been an ordered list, so the page doesn't meet the requirements. Or you could give them some HTML code, some CSS codes, and ask them to find the errors in that broken code. Here, there's 3 errors. You've got to be careful. If you say there's 3 errors and accidentally put in 4 or 5, they'll point out those ones as well. So we've got a mismatch of using an ID selector in the CSS and a class in the HTML. There's a mismatch between the opening H1 element and the closing H2 element, and the link is missing any text to actually click on. So this example's got a mixture of quite common errors like closing or not closing the correct tag, to things that are a bit more sophisticated like classes and IDs, and it's going to quickly show you who's actually reading the code carefully. Again, you can increase the number of errors or make them more subtle as the class progresses through the unit. It could be used as a starter or as a practical task. You could give the class the file of codes and then show them what the completed page should look like and ask them to go and make the changes or make the fixes. If you want to make things a bit more game show, then you can have a go at a version of Bridge of Lies. So you give the class a number of statements and ask them to identify which ones are true. So here we've got 6 statements, and they're all about displaying and positioning web elements from the higher web content. And now it's over to you. So grab a dot of any colour, so it doesn't matter the colour, and add it to any tile in the brick wall that represents a statement that you think is true. If you're feeling confident with your web knowledge, you can add dots to several tiles. There are 3 correct statements to find. So I'll give you a couple of minutes just to have a go at trying to find the true statements. Okay, so we'll go through them in turn. Tile 1 was your display block makes elements stack vertically. That was true. So if you said true for tile 1, you are right. Block makes elements take up the full width and of the display so that the elements would actually stack vertically, kind of one on top of the other. Tile 2, float left causes elements to be centered. Because that statement is false. The clue is in the title. It makes the elements float to the left. So it's not to do with centering, it's to do with floating. Tile 3, display none hides elements but keeps its space. That's also false, because although display none does hide the content, it also removes the space that was allocated to that element. Tile 4, so we had a few votes for tile 4. Clear both stops elements from floating around. That is in fact true. And the purpose of clear is to indicate which side of the floating element should not be allowed to float. Tile 5, display inline prevents elements from sitting next to each other. That one is false. The purpose of inline is to instruct the browser to position elements next to each other. That's why it's called inline. So they're on the same line as each other. And then finally, tile number 6, float right can make images align to the right when text wrapping around that is also true. So that's the third and final true statement. All the subsequent elements will float in beside the floated element if you're using float right. So if you were keeping track, keeping score, then the correct answers were 1, 4, and 6. Those were our correct tiles. So you could do it individually, you could do it in teams within your class and see how far across the bridge of lies the group can get. If they hit a lie, then they're out. And in the swag bag, you can get a copy of these questions, and there's a few other rounds of bridge of lies that you can use with your class as well. There we go. So scaffolding is our next sort of heading. Everybody loves fill in the blanks. So if you're kind of wanting to give pupils some kind of scaffolding, then why not kind of help them write the code and give them the confidence by just getting them to write small amounts of code rather than having to write big long chunks of web code. So one way to do it is to provide them with sections of incomplete codes. This question is a stem from the 2024 N5 question paper. So in class, you could provide them with the incomplete video code and then just ask pupils to fill in the blanks, either in their jotter or they could do it on a show me board. Alternatively, you could, as the scaffolding, give pupils some similar code. So here we've got the audio tag. So this is the complete code for an audio element. The scaffolding is that this code's similar, and you could ask pupils to use that code to kind of adapt it or edit it in some way to make it for video rather than for audio. Hopefully then that gives them all the pieces of the puzzle, and it helps to highlight the fact that they can use code somewhere else on the page to help them answer the questions. The scaffolding also works quite well with CSS. So you can give pupils some code to style a heading, for example, with a background color and a font and a size, and then ask them to write a similar segment of code to style a paragraph by changing it to a different background color, font, and size. So they're really just changing the values. Here we've got another example. This is a higher one. This is a nav bar from higher, and there's more blanks to be filled in, which can increase the level of challenge for pupils. And you could ask them whether they can complete one of the blanks or two of the blanks or all three, and it helps to build in a wee bit of differentiation for you. I know myself, for a lot of the web content, you end up just copying and pasting and then changing the code from one example to another. So this idea of scaffolding code and filling in the blanks can be quite good to see what the pupils can actually remember rather than what they can just go and find elsewhere or what they can copy from a previous task. And it is an important skill because, as we've seen, this type of question comes up in the question paper as well. So the kind of final technique in web is thinking about mind mapping. So I'm sure you're pretty familiar with mind mapping. The pupils will be familiar with it as well, maybe in other subjects. And sometimes starting with a blank bit of paper is often the most difficult thing. Rather than just giving them that blank bit of paper, you could give them a template, again, some scaffolding, maybe just a list of terms to get them started. This is just a wee example of content from N5 Web. Pupils can then work individually, they can do it in pairs or in small groups to come up with their mind map. And after a period of time, you kind of have to judge it based on your class. Stop the activity and then let pupils carousel round the room and add to the lists or agree or disagree with the points made on their peers' lists. It's always good to see if you tell them that they can go and steal answers from other groups. That always adds a bit of kind of fun to the activity, and then they can go and add those things to their own mind map. As a teacher, it gives you a good idea of the kind of knowledge gaps, and the completed mind maps also give you a resource. So it's some nice artwork for your wall, but you can upload them into Teams or Google Classroom, whatever kind of system it is you're using, so that pupils can then refer back to them at a later date. They can use them as part of their revision. As ever, a lot of these strategies could be applied to either programming and software development, or you could use them with databases. And speaking of databases, we're going to move on to Morag, who's going to go into a wee bit more detail about the database activities.
Right, technical bypass. Thanks, Colin. I'm now going to focus, as Colin said, on some active learning and formative assessment ideas that can be used with the database content of the NQ courses. And I'm actually going to start with database structure. What you see in front of you here is one of the resources that was in fact developed last session by the tutor team working on database content. It's a template page that can be cut into individual pieces. If the pieces are laminated before you cut it, then with dry white markers, the pieces can all be reused. So this example here is an N5 task, a paired task is how I would use it. The work in pairs or shoulder partners discuss and agree on the type of relationships that there are, and then use the template pieces to create the ERD that represents the system. And the same strategy works at higher level. And here's a sample task. What this task does is introduce the need to resolve many-to-many relationships between entities. And although that's strictly not something that higher students need to know, it really does help them to understand where those strange intersection relationships come from. And it really does help them at advanced higher level, especially students who decide to do a specialist database project. At least by resolving their own many-to-many relationships, they're more likely to be able to form relationships correctly at advanced higher level. Now we have Erdish, and I'm sure you've all heard of Elvish, so now this is an opportunity to learn Erdish. And this is really important that students learn very early from N5 that all ERDs, relationships, can be read in two directions, left to right, as well as right to left. And telling students that they're about to learn some Erdish introduces a bit of fun. Doing it in a paired activity means they learn from each other in a low stakes situation, so it's not in front of the whole class, and allows them to practice using Erdish reading the sentences. So the top one animal belongs to one classification, and a classification has many animals belonging to it. So it's learning to read in two directions. What we've got here is another structural type activity. It's for N5, and it's getting them to understand that why the primary key is the primary key. So asking them to discuss and agree whether each of the individual fields, the contents would be unique. It might need a little bit of prompting at the very first attempt. So things like, would the first name attribute always contain values that are unique? Is it possible for two students to have the same date of birth? Once they get started, they're usually quite quickly able to complete the unique column and write down the reason. And that's really quite important, that the agreed reason for that decision. Yes, it's unique, or yeah, it may not, it's not unique. And once the table is completed, they should be able to identify a potential primary key. And completion of this task regularly does help them when it comes to something, scaffolding that thing that they need to be able to do in an exam, identifying the correct primary key. And gives us a chance as a teacher to observe, which is really important in formative assessment, and to listen. And similar task at higher, where now we've got terminology of compound keys and surrogate keys, and this is another good way of developing their understanding in that low stakes situation. So let's look at some ideas to develop students' confidence and skills in analysis of database requirements and evaluation of database queries. So obviously we're looking at analysis at the moment, and this is something that is reported each year in the coursework, in the course reports as being an area of weakness for candidates. Evaluation and analysis are both frequently identified. So once again, I've chosen to go for small paired activities, maybe small group activities, low stakes, and have a good of learning from students, an opportunity to learn from peers and iron out any misunderstandings. So there we have a task where we've got information presented with some background details and asked to identify end user and functional requirements. It can be quite daunting, and students do struggle with it initially. So to develop skills to provide and provide some scaffolding is one thing that I've found quite useful to do this. So presenting them with requirements that someone else has created. Like Colin mentioned earlier, they do like highlighting errors. So it's no bad thing to show them some requirements that are lacking in detail, some bad requirements or incorrect ones, and encourage them to discuss why they're poorly formed, maybe rate them on a scale of 1 to 5. They quickly get into the swing of doing that, and they really do like tearing apart someone else's work. The challenge here is to work together to identify the weaknesses and then work together to improve them. Similarly, evaluating their own work can be very difficult. They don't like criticising something that they've worked hard to create, and they can be rather precious about it. That very gentle testing they do, they don't really test it particularly well. They don't like proving that it doesn't work. So working in pairs to jointly evaluate whether a query is fit for purpose that someone else has written, or whether it's accurate, is a good way of tackling that. And I think because it is such a high order skill in Bloom's taxonomy, if nothing else, teachers, it really is useful to try and find some time in class to help develop the skill and help develop students' confidence in doing it. This type of scaffolding, but by providing a checklist that can be used as a basis for their discussion, does help get them to the core of what's important. It's important to remind them that they must answer the question, is the query fit for purpose? Is the query accurate? With a very definite yes or no. And they must give reasons for the response, by referring to the context of the question, to the relevant clauses of the SQL query. And since they haven't invested any time in the creation of the query, they're usually quite happy to be very critical. One benefit that's been mentioned by a couple of people earlier is what formative assessment does show is highlights misconceptions that students form as they learn new content. If we're not careful as teachers, they can join up dots between facts that actually don't exist. And as a result of those strange dots, they may come to conclusions that are in fact incorrect. And the resources that you're looking at here were also developed last year, whether or not you might not have seen them though, in last year's database materials. What we have here are 24 statements that can be cut into individual cards, which is quite a nice way of doing it, so they're not overwhelmed by them. And each one of them, they don't all have misconceptions. Some of them are true statements, some of them are misconceptions. But actively focusing on it in class means that we can kick them into touch quite early. So the 24 statements are all exemplified in what is a movie actor database, and all the details of which are on a single sheet of paper that you can see there. One way to go about it, you can pair it, they can work it in mini whiteboards, they can write it in Jotter, but a nice way of doing it is actually to sort of turn it into a sort of carousel task. I've got strange pronunciation tonight. With workstations, we say 4 statements at each station. Students work in groups to discuss a statement and discuss whether it's true or false. But importantly, of course, the critical thing here, like Kim had said with the peer instruction, is that the decision must be supported with reasons. So, for example, the statement here that says an entity can have more than one primary key, it's false, because an entity can only ever have one primary key. Of course, but the important thing is for higher candidates is that primary key can be a compound key formed by combining 2 or more attributes. In the movie actor database, the role entity has a compound key formed by the attributes actor ID and movie ID. So for something completely different in implementation, what we have discovered I guess as we've got more skilled at teaching this and more experienced at teaching database content at higher, is that one of the hardest implementation skills is definitely grouping. Many students really struggle with it and often confuse it with ordering, and that's understandable because there's a certain element of ordering which does a certain element of ordering which is associated with grouping, so I can understand where that confusion comes from. So a really worthwhile activity is to give each student their own individual set, and it can just be paper, of the 8 records from this competitor table that you see here. Peter, we've made one earlier. So they've each got their own little set of 8, and now they can forming groups that match the requirements of different queries, again, increasing the complexity of the query. And they do that by physically manipulating the records to form individual piles of records in each group. And that physical doing it helps them understand how grouping is applied within a SQL query. It kind of removes that mystery behind it. And allows the teacher to observe how students are coping with the task. Gradually increasing the complexity of the query will help the students understand what happens when data is actually grouped. And another really good way of following that through, or just testing their understanding, is to ask them to visualize the results of a query as a bar chart. So in the bar chart, each group will need a separate bar, obviously, but groups with subgroups will have separate bars for each of those subgroups. So in query 3, the one at the very bottom, for example, which groups by authority but also by level, 2 of the local authorities have 2 bars each for junior and for senior level, whereas Midlothian is the only one with 1 bar because it only in the data in the table, the basic table, which is all available in the swag bag, the students in Midlothian are only juniors. And yes, here we have, and now for something completely different. I'm sure many of you remember fuzzy felts, looking back fondly on fuzzy felts. Well, what you're looking at here is some fuzzy felt coding boards. And the great news is that you can easily create your own class sets of fuzzy felt coding boards. They can be used for some unplugged activities to develop students' coding skills. And what you really need is some stiff cards, what I've used, and these are actually real A3 sized fuzzy felt covered coding boards, is black mountain cards and a roll of black felt with some PVA glue. The coding pieces are created just of paper, and then they're laminated with the keywords and a small piece of Velcro, just the hook side of Velcro, tiny bit on each side, and there you go. Hey presto, you've got your fuzzy felt coding set. You can use it in lots of different ways. You can work in pairs to create queries using the dry wet markers on the coding pieces. It's a low-stake way of coding, great way to boost confidence of learners. You can sometimes be reluctant to try something new, particularly younger learners could be a bit reluctant when they're at a PC. And of course, fuzzy felt coding avoids all the distractions associated with network access, forgotten logins, IT issues, and yes, colleague in West Lothian has recently borrowed 3 class sets of coding boards, of fuzzy felt coding boards. So creating fuzzy felt code is only one use of them. The individual database records that I use for the grouping could be used in fuzzy felt coding boards to build answer tables, or about a standard algorithm, stages of a standard algorithm being laminated and little bits of Velcro, and then asking kids to put them in sequence and beginning to build up that knowledge of how the algorithm looks, that type of thing. But they're also a great way of checking coding skills and a good practice at testing and evaluating skills. So one way I like to do this is to provide broken code. And you might have noticed that the queries on the previous display were broken queries. They were deliberate. I like to provide broken code. In this case, broken queries. Set the task up. I provide students with the query code, an outline of the problem the query is being used to solve. I then tell them that the query is broken and challenge them to work out what's wrong with the query, fix it, and explain how their fix improves the query's fitness for purpose. Okay, so yeah, the little checklist that I mentioned earlier can be used here as well, just to sort of help support that in the initial stages of helping them to develop the skills of identifying the broken queries. We can ask the kids to break it better. They really quite enjoy this. So as a follow-up to the serious testing and evaluating practice, I like to give students an opportunity to create their own broken queries. So go on, deliberately break queries and do it better than I did it. There are some rules that they must adhere to. Firstly, I set the query goal. Secondly, they can only introduce one error per broken query. Initially, I scaffold this by providing suggestions for errors. So they could introduce a syntax error, such as missing quotes or missing commas, a logical error, such as the wrong aggregate function, which is quite common, incorrect formulas for a calculation. A structural error could be added when forming the query, such as omitting a clause or putting clauses in the wrong order, or simply spelling and naming issues. Students then take it in turn to create the query, the broken query on their fuzzy felt coding board and challenge the other student to spot the error, fix it, and comment on the query's fitness for purpose and accuracy. Colin and I have now spoken for a while about formative assessment strategies for teaching web and database content. And I think the time has come for people to let us know what you think about some of the ideas and suggestions we've made. So here's a feedback frame with some blank sticky notes. What we'd like to do is to take a few minutes, let us know what you think about some of the things we've mentioned. Would they work in your class? Which strategies would you be interested in trying? What adaptations would you make? How would it work for you? Can you see how the ideas would be useful in your teaching? It might be you can think about the idea in another area of the curriculum, or what formative assessment ideas do you use teaching database and web that you're happy to share with others. So I'm going to be quiet and give you a couple of minutes. Grab one of the blank sticky notes and just jot down some thoughts. Break It Better is quite good fun. They quite like that. They do like, first of all, they like looking at things that we've deliberately broken, because they do like spotting teacher errors. I'm sure we all know that every time you're talking to them, they're waiting to spot the error. That's suddenly the class wakes up then, but Breaking It Better is really good. They do enjoy that. And the graph visualization of grouping is quite powerful. It does really let you see if they are understanding how things are grouped. So great, thanks for all your feedback and your contributions. It really is heartening to see how much computer science teachers care about their teaching and are keen to improve things for their learners. So yeah, it's really heartwarming that we all share. So now you've had a chance to think about sort of teaching the optional web and database content. I'm sure you're keen to find out more about some of the ideas that we've thought about for mandatory content. So I'm going to pass you back to Colin, who will introduce some ideas that can be used when we're teaching mandatory systems. So back to you, Colin.
Thank you, Morag. So this wee bit is going to be about computer systems. So because systems is very much kind of fact-based knowledge, it's probably the most straightforward area to actually generate quick, easy to access, short response questions, starters, formative assessment activities, plenaries, that type of stuff. So this harks back to one of our previous sessions where we talked a bit about command words and blooms. Have a go at state, describe, explain as a lesson starter. The beauty of this is that it's got built-in differentiation, so pupils can choose the level of difficulty, state being generally the more accessible, up to explain, which presents that bit more of a challenge. So how about this as an N5 starter? Grab a post-it notes and have a go at answering 1, 2, or all 3 of the questions. State the purpose of binary, describe the binary numbering system, explain why the binary system is used by computers. Okay, so loads of great answers. Thank you for that. And hopefully from that you can see the difference in the length and the depth of an answer that you need from state to describe to explain. It's really hard to explain why binary is used in just a couple of words. So the answers I would have gone with, for the state, the purpose of binary, to represent integers, to represent whole numbers. Describe binary, something like it uses 1s and 0s to represent whole numbers. So it's just adding in that extra bit of detail, because it's a describe question. It's not just 1 or 2 words. It's going into that extra wee bit of depth. And then why we use binary, it matches with the on-off switches inside the computer, something along those sorts of lines. But I think your answers are much better than anything that I would have come up with. You could do something similar for hire. So again, state, describe, explain. This time, state the name of one line on the control bus, describe the role of the control bus during this fetch execute cycle, and explain the steps of a memory read operation with reference to the bus structure. So again, I'll give you a wee chance to grab a post-it note and have a go at these ones, and then we'll check back in on answers in a couple of minutes. Okay. So again, just that extra kind of level of detail that you need as you move from state to describe to explain. So loads of good answers. My answers, I would have gone with, well, you could go with any of the 5 lines on the control bus: read, write, clock, reset, interrupt. Question 2, the role of the control bus. It sends the read signal, or it activates the read line, something along those lines. And then for question 3, the steps of the memory read operation with reference to the bus structure. I use the acronym ABCDE. So AB for your address bus to identify the memory location, C for your control bus, sending that read signal, D for your data bus that sends the data from memory to the processor, and E because the instruction is decoded and executed. That's the way I remember it, which gives me something to fall back on. And again, this might just be a quick starter at the start of your lesson while kids are coming in and logging on and taking off their jackets and stuff. But all 3 of these higher questions could quite easily appear in a prelim or in an SQA exam. In fact, if you are marking the 2025 question paper as we speak, then the question this year was state how the processor makes use of the control bus during the fetch execute cycle. So starters don't just need to be a filler task to get people busy. It could be by putting in these command words that you can provide that sort of vital exam preparation. This type of starter could be applied to just about anything that needs to be covered in computer systems. And again, as you've seen with a lot of the strategies, it could be used for kind of any other part of the NQ course as well. So the next bit is just more sort of formative assessment activities. There's a kind of whole sort of mixed bag in here that are really designed just to engage and as well as assess your pupils' knowledge of computer systems stuff. And again, the focus really is on N5 and higher content, but there's nothing from stopping you putting some of these kind of activities into an S1 or an S2 computer systems unit. In fact, I know of a school that uses baseball caps and table tennis bats to represent binary as their P7 induction lesson. So, you know, it's never too young to start them. If you don't want to go down the hats and bats route, then it's quite an easy activity just to set up with whiteboards. So you get the pupils to work in groups, ideally groups of 4, 6 or 8, and they write the place values 1, 2, 4, 8, 16 on the wall or the board or the window, and then each member of the team stands under one of those place values with their whiteboard and holds up either a 1 or a 0. And working as a team, they have to represent the number that you've given them. You can make it competitive by having a binary shootout. So have a list of numbers and then say 1, 2, 3, go, reveal the number, and the team that can make that number in binary first wins, and the other team are out, and you could do it as a sort of last team standing. Whiteboards, show me boards, and formative assessment, they go hand in hand. If you've read any of the Bruce Robertson stuff, Teaching the Delusion, then you'll know all about that. Binary, floating point, two's complement, naming vector objects, naming attributes of vector objects, anything like that can quite easily be answered with a wee quick show me board, just as a knowledge check. Sticking with that kind of binary theme, many of you have tried some sort of version of binary bingo. There's loads of online resources out there that you can download and you can print out. Alternatively, you can make your own binary bingo cards. There's loads of online binary games as well. So the Cisco one, there's a link for it there. It's quite good. There's plenty of Bluekits and Kahoots and quizzes that you can use. You can make up your own, you can adapt things that are there. AI is really good. So you just ask AI to give you a battery of binary questions, and it'll do all the kind of hard work for you. And you can use those questions in any number of different ways that you want in terms of formative assessment. At higher, rather than just focus on binary, why not try a floating point relay race? The first person in the team comes and collects a question, answers it either individually or taking it back to the group, and then the next person comes out for the next question. The only downside to that is that it can be quite frantic. People tend to get quite competitive with it. So sometimes quite good to have assistants that do the marking for you. And it's definitely one that I would keep for a Friday afternoon. As I say, it can get quite tense with the competitiveness of your teams. One retrieval practice or task that can work quite well is an escape room. There's loads of different ways that you can run escape rooms in class. There's loads of different templates that you can get online. The way I've done it in the past is to have 6 rooms in the escape room, and each room has got 4 multiple choice questions per room, and a team only escapes onto the next room to get the next set of questions if they come up with the correct combination of A, B, C's and D's for that words, or for that room, sorry. So in other words, basically the team had to get 4 multiple choice questions correct to then get the next set of multiple choice questions. And again, AI can be really good at helping you come up with the questions or come up with the answers or come up with the kind of distractors for your escape room as well. If you're teaching the kind of security side of things, then STACS have come up with some really good sort of security and encryption resources and tasks. So what you can do is you can encrypt messages. The messages could be about anything, but you could keep them systems related if you wanted, and then get the class to decode those secret messages. Again, you can make it competitive. You can have a race. They can come up with their own appropriate messages for partners to decrypt. There's loads of different examples. Here's just a few of them. Some of the ones that kind of STACS have come up with. So you've got Morse codes. Each letter is replaced by a sequence of dots and dashes. Quite old school, but they might recognize it. Number replacement. So each number in the alphabet is represented by a number. So A is 1 and Z is 26, and you use those number sequences to create your letters and your words. A keypad cipher, again, quite kind of old school. It's like old school text messaging if you're of a particular vintage. So for the young people these days, if you have to make the letter H, you're going to press the number 4 twice. To get the letter Z, you need to press the number 9 4 times. How did our thumbs survive back in the day? There's loads of other examples. There's Caesar ciphers, there's keyword encryptions, there's pig pens. In the slides that I took these kind of screenshots from, they're all in the swag bag, but you can also find them as part of the kind of STACS resources from a couple of years ago as well. As mentioned earlier, Blue-Kit, Kahoot, quizzes, they can be really good ways to kind of finish off a lesson as like a plenary. There's loads of different plenary ideas that you can just adapt to the systems unit. What can be quite good is a couple of rounds of here's the answer, what's the question? So you're giving them an answer, like turn down the screen brightness, and you're asking the class to come up with, well, what's the question that matches that answer? So at N5, that would be something like, how can you reduce the energy, or what ways can you get computers to use less energy? It can also be quite a good way to focus on the command words with the pupils. So encourage them to create the questions that don't have question marks and kind of model those sort of states and explains and describes. So in the kind of ideal world, the answer to this question would be, or the question for this answer would be, state one way to reduce the energy use of a computer. The answer that you give the class might generate more than one possible question. So for example, if your answer was negative 128, then that could be a 2's complement conversion type question, so convert -128 using 8-bit 2's complement, or it could be a question about a range of 2's complement values, like what would be the largest positive integer you could represent if the largest negative integer was -128, so that you then get this kind of variety of answers in your class. Everyone loves an odd one out, a bit like the Bridge of Lies earlier. So you can give them 4 statements or 4 answers. You can ask pupils to identify which one is the odd one out. So for example, with this one, we've got increase the data bus width, increase the number of cores, increase cache, increase fan speed. And again, a question like that provides a bit of differentiation. The pupil might be able to identify that D is the odd one out, but can they explain why? And it goes back to those kind of PI questions from earlier. It's all about the why. Can you actually explain why it's not a way to improve computer performance? And the follow-up question might then be, well, what would be another way of increasing computer performance? Which, of course, your answer would be increase the clock speed. If you've got a class that likes a bit of competition, then why not try something like win, lose, bet? You can either set the questions or ask pupils to come up with questions for each other. And basically how it works is each question is worth 5 points. A team can bet a number of points depending on their level of confidence answering the question. If they get the question correct, they keep the points that they bet. And if they're wrong, they lose those points. And the winning team's the team with the highest total points or bets at the end. So hopefully from that, there's a few new ideas to add into your collection. Most, if not all, could be adapted or applied to any of the other areas of the course. All the starter ideas could be plenaries and vice versa. In the swag bag, you're going to get examples and templates that you're more than welcome to use. That win, lose, bet is there. And again, it's something that you can kind of adapt for yourself. You could use these when you're actually delivering the systems content. You could use them as revision after, weeks after, months after completing the teaching. You could use it as prep for part of your prelim revision or final exam revision. And I'm sure you have loads of your own ideas or activities that you like to use in your teaching. So it'd be really good if you could share some of those on a post-it during the feedback at the end of this session, or if you wanted to post them on Stacks Connected as a way of everybody getting new ideas and new kind of activities that they can use with our classes. So it's goodbye from me, and it's over to Michelle, who's going to focus on some of the SDD stuff.
Moving on from that to something more on topic, I'm going to take you through some starters, plenaries, and some active learning activities that can be used for formative assessment purposes within software design and development. For me, formative assessment takes place in every lesson. It starts as soon as the students enter the classroom through my starter activity. These simple and quick tasks, mainly individual-based tasks, help activate prior learning, and it gives me instant feedback so that I can adapt my lesson to suit the needs of all. Because starters are low stake, students can participate without the fear of failure. You'll have noticed a few different starter techniques on the screen just now. These starters encourage confidence and they help me assess student understanding in a relaxed setting. Importantly, they all promote some form of retrieval practice. By recalling information from memory, that helps our students reinforce long-term retention. There are many different ways to ask starter or plenary questions like we've heard already tonight, and it is really your knowledge of your students and their individual learning journey that will allow you to pick the most appropriate ones. Now let's talk about plenaries. Plenaries are essential for consolidating learning. They help students summarise what they've learned and they reinforce those key points. Plenaries often encourage reflection. It allows students to think about what they've learned, how confident they feel, and what do they need to revisit. So that's the kind of metacognition that's key to developing our individual learners. And again, on screen, I've listed a few different types of plenary techniques. For me, a strong plenary ensures that the learning in my lessons continue from the very first moment through the starter to the very last minute just before they leave the classroom. They give us a valuable snapshot of what our students have taken away in each individual lesson, and this will help us identify whether we need to reteach anything or whether we can move forward with new content. If you take a wee second, you can have a wee read at some of the plenaries on screen. And what you'll see is plenaries and starters are pretty interchangeable. So you can use it for a plenary, you can use it for a starter and mix things up. Moving on to a wee starter activity. There's so much content to cover for software development that it makes the possibilities and the different styles of starter and plenary questions, like I've shown, are pretty endless. I always start the topic and individual aspects off with a really simple starter to build that confidence. So these are just really quick questions that we can put together to forum parts of past papers, something really easy and quick to implement in our classroom using a mini whiteboard. So when students reveal their answer, it's very easy for me to identify who or how many have got the answer correct and therefore need further support. So here's an example of this type of question. And I'm going to use a poll just now to get your answers. But in the classroom, like I say, this would be a mini whiteboard or a show me board activity. I'll give you a few minutes to have a wee look at the flowchart, have a read over it, and then you can vote on the poll. What I would ask is, please don't click poll at the end because that will end the poll for everybody. If you could just submit your vote for me. So now you've had a wee chance to read it, okay? If the two cards that were drawn were a 9 and an ace, what would be the correct answer? So you've got a 9 and you've got an ace. So what you could say at this point to the young people is that maybe with a 9 and an ace, they might not have an answer. And again, that's getting them to read and understand your flowchart to come up with there isn't a value for your answer. Okay. If there's a 9 and a 6, what would be your answer? Again, same scenario, give them a wee chance to look at it. We don't actually have an answer. So this question is, if there was a 9 and a 4, what's your answer? And I'll let you vote on that one. So we've got a 9 and we've got a 4. And I'm going to end the poll. We all agree that it would be 5. So that's something nice, quick, confident that'll help build their examples. And once you've done that, you can move on to some more challenging questions. And these kind of challenging questions will allow you to dive deeper into each individual student's learning and provide them with a little bit more feedback and direction for improvement. So on the screen, what you will see is a harder type starter question. There's just a little bit more to that question. There's 3 parts to it. It'll just tease their thinking more than just the previous question. You're ready to move on to your classroom learning, and one of the ways that I really like to do that is using Parsons puzzles. For me, when students engage in tasks like problem solving and group work discussion, we get valuable real-time feedback. We can observe their reasoning, their justifications. We can listen to the questions that these type of challenges bring for the young people, and we can assess how confident they are in dealing with these different challenges before we move into traditional summative assessment. And feedback that we can give from active learning is it's immediate, it's low pressure, it's easy for the young people to take on board, and it's really, really actionable for them. Like I say, one of my favourite activities for this in terms of software development is Parsons puzzles. It's really, really good to help in understanding with programming. So what is a Parsons puzzle? Well, essentially, it's an activity where students are given some completed lines of code, but the lines of code have been jumbled up. So the challenge for them isn't to write the code, because that can be at times quite daunting. It's to take the code that they've been given and rearrange it to form the correct sequence so they've got a correct working programme. And the purpose of this is to help our young people develop a stronger understanding of programme logic and structure. It shifts the focus away from syntax, when for young people and for new coders, this can be a little bit overwhelming. So instead of it kind of worrying about syntax and getting things right, it encourages them to critically think about how the programme's built and how it's put together. So here's how it works. I would always start by giving an overview of the problem statement, highlighting what the completed problem should do so that students have that clear understanding of the task. And as a new activity, I ensure that I'm reminding my students about coding constructs and how they're written. The next thing I'll do is I'll give them a programme just like the one you see at the left, at the right of you on the screen. I'll then tell them a couple of things that they should notice about the code. It's not got indentation and it's not in the correct order. So if we take the example on the screen, you can see what the programme is expected to do, display how many times a fruit of the user's choice appears in that preset list. So depending on how much scaffolding you need to give your students as a whole class, as a group, as an individual, you can remind them that everything inside a loop should have indentation. We need to show the start and the end of the loop. If you're using a total or a count, we should initialise that at the beginning of the programme so that it starts afresh every time. You could even say something as simple as a reminder, can you print the output on the screen before you take anything in from the user? And like I said previously, you'll know your students best as to how best to scaffold and support this. And the idea is that as students become more advanced in their code comprehension, you can reduce that amount of scaffolding. We can even introduce some lines of code that are not actually needed in the programme, or as well as just getting them to reorganise into the correct sequence, you could get them to put in some indentation as well. So this can be done as a paper exercise. You can do it using your mini whiteboards. You can use free software that you can get online, such as Hot Potatoes, that will create your own interactive Parsons puzzles. You can even use more rags of fuzzy felt boards from earlier on as a means of allowing the students to reorganise their work. It can be done individually to provide individual feedback, or as a peer learning and peer assessment activity, or any way you feel that it would benefit the young people. So Parsons style exercises with automatic gradings are also available online, and for us that makes them even more accessible and practical. And I've put some details in our swag bag. So now I've talked to you about a Parsons activity. You know what it is, you know how to do it. We're going to have a wee shot on our own. So what you're going to see on the screen is that there is a programme that needs to be sequenced correctly. So if you all get a post-it note, you can use the line numbers down the left-hand side and reorganise this programme. So we need a programme that asks the user for a number and then displays how many times there is a number in our list, 5, 12, 7, 3, 18, 19, that are greater than that user's choice of a number. So I'll give you a wee couple of minutes to have a read at the code and try to reorganise it into the correct sequence. We've got some really good solutions on the screen just now. What you will notice if you have a wee look around at different people's post-its is that there's different ways of putting this programme together in certain areas. So some people have done 1, 4, 8, but those are all declare lines, so they could really be in any order. I'll give you another 30 seconds just to finish off your answers, and then we'll have a wee look at the correct solution. Okay, so let's see what that correct solution was. So how close were we? Parsons puzzles have lots of benefits. They help build that confidence in an individual, in a group, in a class setting that's relaxed, low stake, low pressure. It encourages all our young people to think logically. It reduces the frustration of having to think about the syntax and getting things really syntactically, grammatically correct. We're giving them the code, we're just getting them to think, how does this all come together? What goes inside the loop? What goes inside the if conditions? And they're really perfect for differentiation. They help us enable and understand where our students are, even if they're not ready to write that code. So rather than jumping straight in and getting them to write code, bring it back to basics, let's explain the code, let's talk about it, and let's see if they can really understand how to put things together. There are many other learning activity methods that we can use to support students' learning and understanding of software development, especially in terms of code comprehension. And you should be seeing some on screen just now. There's examples of all of these, how to do it, how it works, and some tasks in our swag bag. Just remember that all active learning can be used as formative assessment. It's turning hands-on collaborative activities into opportunities for us to provide feedback to young people, for feedback to be on peer-to-peer basis, or to give them the opportunity for individual feedback to help progress their understanding during the learning process. And that's really, really important. Formative assessment is not about the end goal, it's about how can we develop that learning throughout the way. So active learning becomes formative assessment when we observe our young people doing that, and we observe them responding to their learning journey. When young people can generate evidence of their thinking and can improve on their thinking process independently. When we give young people the opportunity to reflect and to feedback. And of course, most importantly, it informs next steps in learning for young people. Where do they need to revise? What do they need to re-go over? And what do we need to reteach because our young people have not quite got it? So I hope that this kind of wee short session has given you some food for thought as to how we can embed formative assessment into our lessons for software development and code comprehension. Pretty much the same that other tutors have said tonight about the techniques being interchangeable. The nature of these tasks can not only be used for software development at National 5 and higher, but across the BGE as well as across other units of N5 and higher. It's really about being creative as possible to keep the lessons active, to ensure our learners are leading and actively participating in their own lessons. So I think that's enough for me, folks. So I'm going to pass you back to Kim for our little closing session.
Thanks, Michelle. So before we grab some feedback for you, I know we're running a wee bit behind, but I wanted to let you all know that we've got another one of our goodie bags for you to take away today. And we've mentioned it a lot already, but we've packed it full of examples and templates from each of the units that we've covered tonight. We've also put together a wee folder called Formative Assessment, and that's going to be filled with some one-pager information guides for different formative assessment techniques that you might want to have a little look over if you like a little bit of light CPD reading. A link is included to the swag bag on this frame, but it'll also be put into the assessment space in Stacks Connected, so don't worry about losing the Miro link to come back and try and find it again. We'd love if you'd share with us your thoughts about it. I know we kind of did this halfway through, so this is maybe more thinking about the second half. Let us know what you've liked best, what's been the most useful, what you'd like to see more of or less of, and this will hopefully help us shape what we're looking to do when we move forwards. With that in mind, we'd love you to know if there's anything you'd like us to cover in future sessions. We'd welcome any suggestions you might have about aspects of assessment you'd like us to focus on. So please take a moment to fill out a post-it pad and give us any feedback that you might have. S'il vous plaît. those of you who don't know what Plan C is, this was basically run by Quinton and Peter Donaldson. Perfect. As always, everyone, thank you so much for your comments and suggestions. We really do take them sort of on board when we're thinking about what sessions we're going to run next time. If you haven't quite finished, don't worry. There'll be more time to go back at the end once I've passed on the contact details. So as you can see from the roadmap here, which I know is on the Miro, but I'm not sure why Google hasn't updated. Hopefully I'll update in a second. We're now at the final of our assessment session prior to the summer break. Details are still to be confirmed as to how we're going to be returning after the summer, whether that'll be more online sessions or maybe face-to-face events, visiting council areas. I think this will really just be assessed on the feedback from you and what we feel is needed as a kind of collection from computing scientists. So please, if you feel like there's anything you've missed in the previous feedback frame, go back and add it before you head off tonight, as it will make a difference for us when we're making our plans for moving forward. Between now and our next session, we're obviously going to be contactable to help access resources or to raise queries through STACS Connected in the assessment space. So feel free to pop up a wee post in there. If you've got any issues with resources or if you've used them and how you've got on with them, also let us know. Maybe you could have a go at writing some stems or questions and you want to run them by us. We're happy to help wherever we can. For additional communication, updates are going to be posted in the usual places. So STACS profiles on X, Blue Sky, posts on the Computing Science Scotland team will all be available. And also we'll try and get in touch. You can get in touch with us directly with our hello@stacs.scot email if you have any specific questions. So that's us for tonight. Thank you so much for joining us, everyone. And over this academic session in total, it's been great to see so many of you computing science teachers keen to learn more about assessment and taking time to participate in the upskilling sessions we've been running. I hope some of you will stay for the after party, last one of this academic season, but if not, have a fabulous summer break when it comes. I know we're all limping towards the end now, and we will see you on the flip side after summer, hopefully. But thanks very much for joining in, guys. Oh, hearts emoji, thank you.